Hello and welcome. Welcome, you faces, back to another idea.org. This is the equivalent to the online Duke of Edinburgh Award. This is an online version of it. And today we are going to be doing random coding badge as requested by several people. Today's the day we're going to do it. I did promise when I get to 140 subscribers I would do it. So no, so 240 subscribers. And yeah, here we go. So let's go ahead and redo the badge. Okay, I just have to go ahead and press the reboot do button one more time. Redo badge. Why is it redirecting me back? Find the badge, and we will just make sure that we can redo it. Give me a second here. Where is the random coding badge gone? There it is there. Redo badge. I don't want. Okay, why are you giving me? Okay. I'm going to pause the video and I will fix this very momentarily. Okay, so fix that issue. Okay, so welcome to Coder Dojo, Random Coding Badge, a badge all about randomness in our world using proper programming language Python. What is this box? This is a challenge box. You will see this presented throughout the compilation of this badge. Challenges must be completed correctly before we can proceed to the next task. This is your first challenge is to simply get you started by just clicking I am ready below to start your journey into learning coding with Python. Okay, so let's do that. Go ahead and press to the next task. It's just telling us that this is a feedback box. It will tell us if our answers are correct or our answers are wrong. We'll move on to the next one. What is randomness? Randomness is all around us, from the butterfly effect, which means that we can't know what the weather will be like next week, to radioactive decay, which powers nuclear stations. Randomness is very useful things for us to use in programming to allow us to make realistic computer games or even to shuffle your music. What we're going to do in this badge is look over the various bits of randomness and how we can use some of these in programming. We will also be learning some programming techniques as we do this. Let's start with a simple example of randomness. Rolling 2 dice using a code editor below. Press play to run the code. A few times, note how the numbers change. Okay, so we'll go ahead and do that. 1, 2, 3, 4, whatever. The numbers change over here on the right. Import random, minimum 1, maximum 6. We're going to print the dice, and we're also going to print the amount that the dice has generated. Okay. Right. The Python code uses a function from the random library to produce random integers. And you know what an integer is. If you haven't seen this, then make sure to check the playlist that will be linked up at the top right, I believe, or somewhere. The playlist, and I'm pretty sure I've done a video on integers before. But basically, integers are whole numbers, so like 1 through to 999 billion. Okay, moving forward. Between the minimum and maximum values, which is in this case are 1 and 6. Let's edit this code to build a lottery simulator. You will need to have 7 numbers, 6 normal numbers, and a bonus number. All values need to vary between 1 and 49, so you can't go any higher than 49 in this instance. To edit the code, you will need to change the max value from 6 to 49, so let's go ahead and do that. Change 6 to 49. Okay. Go ahead and go down to the next one. It says change dice to lottery ball. So we'll go ahead and find dice, and we're just going to change that to lottery ball. We'll go ahead and copy that, and we'll just go ahead and paste that into these two down here, and that's what it's told us to do. Okay, next thing it's telling us to do is copy and paste the last print statement until you have 7 lines. So let's go ahead and copy these two. 1, 2, that's 4. 1, 2, 4, 6. We need one more, so we'll do that and we'll get rid of 1. That means we have 7 lines of prints. Okay, so what we're going to do now is it tells us, it says, until you have statements on them, change the numbers for the first 6 statements to so that they go from lottery ball 1 to lottery ball 6. So what we're going to do now is we're just going to copy lottery ball. So we're just going to change lottery ball from the first one. So we're going to go 2, 3, 4, 5, 6, and then it tells us to do up to the first 7. Okay, and then the last one, it tells us to change the lottery to bonus ball. So we'll go ahead and change it to bonus. And then we shall that. No, I'm not spelling that right. Okay, make sure you are spelling it right. Bonus ball. Make sure that there's no space. There's one space in between, and then that's going to be left blank by the looks of it, because our bonus ball is going to be generated randomly. Okay. So let's go ahead and move on. With the code, you have now made a basic lottery pink ball picker. Answer the following question to move on to the task. What library are we using to import Python? So let's go ahead and run it. And there we go. We've got a random number there. So let's go ahead and what library are we using to import it? We are using the random library. So we'll go ahead and copy that and just paste that in there for ease. Check my answers. There we go. You got it. So you can import other libraries into Python. So next. Okay, so now we can produce random whole numbers, integers. What happens if we want to generate decimal values, floats? Again, I have done a video on this, so you can go and check the playlist. Well, floats are basically quick demonstration of what floats are. They are numbers that are basically decimals. So you can go from like 0.1 to 0.9 and so forth. So let's go ahead and continue on with this. Change random.radiant minimum to max on the bonus ball line to random. Okay, so we'll go ahead and copy that. And we'll go ahead and just paste it right here. And then get rid of the brackets because we've already got 2 brackets already. Now it says run the program several times and then select what you think the function does. So we'll go ahead and press play. Okay, what are we missing? What are we missing here? What are we actually missing here? Okay, there we go. We want to get rid of the minimum and the max in between. That's what we're all missing. Now we're going to generate it. You'll notice the pattern. So we are generating a number between 0 and 1. Is what we're going to be doing. That's what we're doing. We're generating a number between 0 and 1. It's giving us a decimal value. So let's go and press check. Okay, that should be working. Definitely should be working. Should do 0.1. Is that working? Okay, what's going on? I'm just going to refresh the screen just because I don't think that's working. Okay. Oh no. Oh no. Now it's. Oh no. I'll be back in a second. Once I've got back to where we were. Okay, so we're back. So, moving on to the next thing. Generating our own randomness. The random function uses the pseudo-random number generator, pring. The numbers aren't really random, but it takes a long time for them to repeat. Another way of developing randomness is through a middle square method. What you do is start with an initial number called a seed and multiply it by itself. Square it. This should produce something with twice as many digits in it. You then take the middle set of the digits and use this as your next seed. Let's try it. Run the code and use 3248 as your seed. So we're going to press run. 3248. So we're going to press that and go ahead and press check and press run. And press enter, sorry. And that should. The squared seed number is a ridiculous number, and a new seed number is that number. So now it's telling us to import 3,248. So we'll go ahead and just rerun it. Paste that in. Not there. And then our number is 5495. So we'll go ahead and paste that in. 5495. Check. There we go. What's the output speed? In this code, we have a few concepts that you may not understand yet. In the next few pages, we shall explore these concepts. You got it. Let's move on to the next task. Okay, so now we're going to move on to loops. I have explained these as well in the previous videos, but we're going to go through it in this one also. Loops. A loop runs the same bit of code several times. It checks that something is true, and if it is, the conditional code in the loop runs. If the conditional is no longer true, the conditional code doesn't run. That means basically if something is true, it's going to run. If it's not true, it's not going to run. Quite simple. The code doesn't run anymore, and the program continues to finish. Let's look at 3 ways you can use loops. There's different types of loops, such as while loop. These loops repeats code as long as the condition is true. It is important for a while loop that condition can also be false. So while it's false, it can do this, or while it's true, it can do that. Okay, this loop represents a code as long as the condition is true. It's important for a while loop. It's important for a while loop that the condition can also be false. Yeah, okay. And here's an example of it here. So count equals 0. While count is less than 9, it will print the number and then the number that the count is on. So that would be 0. It would print 0 because count is 0. Count equals count plus 1. So it's going to then start printing out numbers higher because until it reaches 9, and then the loop will just stop. Okay. Now we're on to for loops. This loop represents a code a set number of times. In this case, the loop variable I starts at 0 and increases by 1 each time. It stops when it reaches 9, and it doesn't run when it is 9. So this code would print the numbers 1, so 0, 1, 2, 3, 4, 5, 6, 7, and 8, repeating the code 9 times total. So for I in range, the brackets are just something that you do to tell the code that this is a function you are doing. So in a range from 0, to 9. So from 0 to 9, and then it's going to print a number, the word number, and then you're going to print I next to it because that's what you're going to print. You want to know what the number is. Okay. Now we move on to our next one, which are nested loops. You can also put loops inside of loops. This is useful if you want to check rows and columns, for example. So let's say we're playing noughts and crosses, and we wanted a player to know, like, okay, you've gone up the top left as in a square. We also want you to now place one down the bottom right, or wherever you want to. That is a grid, and this is how you create grids through nested loops. Okay, moving on. So there is an example below. For I in range, and we've seen that up above, 1 through to 9. For j in range, so what we're doing there is we're saying for I in range, 1 through to 9. So let's imagine it as a panel, okay? But we can go ahead and bring up paint for this. This is better explained like this. So let's say we have, and I'm just going to use a pencil for this. So we can say, let's say we have an x here, right? So this would be 0 right here. We'll just go ahead and do a 0 there. That would be 0. And then we would go another x, okay? And that would be 1, 2, and so forth, all the way up to 9. We'll go ahead and put 9 there just as a representation. Okay? And then what we're going to do now, so for j, so remember this is I, so we're going to go ahead and just do this, and then this is a I. So this is I, okay? So now we're inside of the loop. Oops, a daisy, didn't mean to do that. Now we're inside of the loop. We want to then go down a column as well. So imagine it's like this. So now we're going to say for j, so we're going to do a j here. Instead, it's going to go down. So, for example, we would do a j here as an example. Okay, there's a j. But this time, it's going to fill it directionally downwards. So it would go 0, another x here, another x here, and that would be 1, and this would be 2. Okay, so now you can kind of get the idea. That would be our grid. Okay, so now remember you are filling it from 0 to 2, so it would be like this. Okay, this would be your grid. If it was to go to 9, it would be a lot bigger. But this is position 0. So this is position 0, right? And this is position 0 as well. You've got 2 zeros here, and you've got 2 1s here. You've also got 2 2s here. Along here is 2 2s. Okay. You got that? And this would be 3 if we were to go ahead and do it, and the 3 would be down here. Okay? So let's say I wanted to find this value in the center, right here. Okay? Let's say I wanted to find this x. I would say, I would open a bracket like this, and I'd say I. I would say at the number 1, because I want to go down. Yes. So I would say I 1 like that inside of a closed bracket like that, and I would say I next to it like this. Okay, so we're telling I to go to 1, and then what we're going to do is we're going to say now J. It's weird J, but okay. J go to 1. And just like that, that would then find the center. That would find the center circle. So now hopefully you got a little bit better of understanding it. That's how you would create a grid. So let's go ahead and continue on. Okay. How do you know which loop to use? An easy way to remember which one to use is to use the keywords in the sentence. Know what you're in for. Do you know how many times it will loop? Maybe looping for a while. You're not always sure how many times it will loop. Okay, test your knowledge. How many times would the following code print the statement? So for I in range, remember what range is from 1 to 9, or whatever numbers you put in there. So print hello. It's also going to print that as well. How many times would it do it? It would print it 8 times. That's how many times it would print it. Because it's already printed this one. And check that. And see, that's already right. Yep. How many times would the following code print the statement? So count equals 3, while count is less than 9. So count is going to be it's got to be less than 9 before this while loop will run. In which case it already is, because remember we've got count is equal to 3. So this will run, and then it's going to tell count to continue counting. When it gets to 9, it'll stop. So that's how many times does the following code run? So it would do 3, 1, 4, 5, 6, 7, 8, 9. And how many fingers you got up there? That's the difference. It's 6. Okay. Because it's counted a further 6 times to get to 9. So let's go ahead and move on to the next task. Conditional statements. One very important feature in programming is conditional statements. These statements are used to evaluate if something is true or false. So, a bit of code, okay, that's a bit wrong grammar there, just saying. If so, a bit of code is run, else something happens. Okay, so that's saying, if my dog was red, then I could have candy floss. You get the point. It wasn't a very good statement, but you get the point. If he was pink, I would have candy flasks. If he wasn't pink, then, I don't know, he'd probably be a weird dog. Okay, moving on. So for example here we've got my age is equal to 22. If my age is equal to 22, print you are young. You might want to do something like this, something different in this condition, if this condition isn't met. So if something is true, you do one thing, and if not, you do something else. Here you would use it, an if and else, as shown in the example below. My age is equal to 222. If my age is equal to 22, print you are young. Else, print you are old. So that will always print you are old, because my age is still going to be equal to 22. Finally, you may want to check a set of conditions. If the first isn't true, try the second, then the third, and so on, and continue it on until you have an end goal. Okay? This approach uses if followed one or more else if statements. Okay? So let's say, for example, you had a car that was red and a car that was blue. You also had a Lamborghini. So you could say, if my Lamborghini was red, else if it's not a Lamborghini and it's not red, then it can do this. Else, if it's anything else apart from the cars that we've mentioned, then you can do whatever you want. So as you can see, elif, that is the difference between else. So that's else, that's anything else that's happened afterwards. Else if is basically saying, well, if that's not true, then make sure to check to see if this is true. It's like having a second check within the if statement. That's why if you take the first two letters off, it's actually an if statement. Okay, moving on. So we've got my age is equal to 21. If my age is equal to 22, print you. Okay, weird. You are young. Elif, my age is less than or equal to 21. So if you're not over the age of 21, it'll print you're really young. Okay. However, if this statement above is not met, or this statement below it, then it will print you are old. Conditional statements play a vital role in program, leading to different results based on the user's input. Question time. Answer the questions below the following piece of code. Hint, copy the bit inside of the quotes. Okay. If my age is greater than 17, print you are old enough to vote. Else if, that means that if this statement is not true, however, you want to check something else is true, you would say, so else if my age is greater than 12, so if somebody is over the age of 12, it will print you are a teenager. Else if they are older than 4, it would print you are too young to vote, because who's going to be voting at that age? It's ridiculous. And then again, if these statements are not true, then it's going to try and say, hey, everybody else who's in the crowd, you're old enough to own a computer. So, what's the questions we got? What would print from the above bit of code if the variable my age had the value of 12? So we'd find 12. Else if my age, so it would say you are a teenager. So we're going to copy that and paste that there. Else if my age is greater than 4. Okay? What would print for my variable if the string value was of 17? So it's saying here, it's 17. So it's trying to trick you by saying it's a string value. A string value can be, again, I've also done a video on that. A string can be numbers, it can also be letters. So they're just saying that the number 17 in words, and if you are older than that, then it will, oops, okay. So what went wrong there? Else, if you're seeing this message, you got the first question wrong. Well, yes, we did. Because the actual first question is you are too young to vote. That's the first question. There we go. That should work now. There we go. And then the last one we are going to paste in here because that is the right one. Else, if you are older than 17, because if you notice it says if you are above the bit of code, variable my age, it would print that. Okay, moving on to the next area. On the next section, whatever. Okay, functions. Like conditional code in loops, functions are another way to run specific bits of code. Functions allow you to use the same bit of code many times without having to type out each time and use the parameters to produce different results each time. In the example below, we have a small function called timetables. Run the code to see how changing the first parameter from 1 to 4 to 12 produces completely different results. So we'll go and do that. Got loads of numbers generated, 12 times 40, and there we go. So now it says change the number, there we go, to something like 12. We'll get a completely different result. Yeah, it doesn't actually do anything. Okay. So that's good to know. So let's go ahead and continue on. Understanding code. Let's try to understand how the code in the editor works. The middle square function starts on line 1, where it's defined as def. That's how you make functions in Python, it's def. And ends on line 21, where the function returns the new seed result. You can see from the green hash comment lines that the code in between does. The program starts on line 23. A while loop starts on line 24 and runs while check is false. If else conditional statements, lines 29 to 34. Check for the user input, and once there either 2, 4, or 6 comes through, the function then runs. Once with the result printed to the screen, and the while loop stops to check for true. So basically what it's doing is it's running a check, it's using a while loop to run a check, and if the check passes, it's then allowing another while loop to run. So, we'll continue on then. Okay, so now we need to understand loops and exception functions to work. Let's change the loop to run the function 20 times. Highlight the code from check equals false, line 23, to the end and delete it. Once you've done this, put the following instead. So what we're going to do now is we're going to do line 23, check, and then it says, and then run the function 20 times. Highlight the code from check equals false to the end. Okay, so we're going to go ahead and do this. Yes, we do all the way down to the bottom like this. Delete it. I'm just going to copy this code here because that's what it tells us to do. I'm just going to paste that in there. Now we press play. We get an input seed number, which is great. Also, just going to have a number in here. We get a number now. We have to do two numbers. If we do like 22, not here. I keep pressing the wrong one. 22. We want to log into 22 and press enter. There we go. Okay, moving forward. Now we're in the code to see the difference. Yeah, I saw the difference. Now input the following, find the answers to get it out. So it's telling us now to input 344. So we're going to do exactly the same and do that. So we'll go ahead and type it, run it again. 344, press enter. And there we go. Output seed is equal to 344. That's the one in colour. That's what it's told us to. We'll go ahead and paste that in there. Okay, and then it's going to tell us to do 32. So we'll do 32. 32. And as you can see, we've got loads of numbers. We'll just go ahead and place 32 in here. That is our output seed as well. If this is wrong, then let's try this again. 34. 34. Okay. Check. Okay, so it is wrong. Okay, so then I've missed something out. What have I missed out then? Obviously missed something out. So let's go back and see if I've missed something out important. What line did it say? Line 23. So yeah, line 23 is here. Right? Yeah, it's definitely line 23. And then it's telling us to copy this and paste it in. That's what it's telling us to do, isn't it? So we're going to do that. Paste it in. Just make sure that it has actually done it properly. Okay, so now if we go ahead and enter those numbers again, so 344, 344, right? And we press play. Oh, so if we press enter, 344, 344. Okay, and then there's our result, 0, 0, 0. So we go ahead and place 0 in here, 0, 0, 0. Check that's right. No, it's not right. Why is that not right? At least you just did this a second ago. 1 second. Why is that not right? Huh, okay. Why is that not right? Oops, daisy. Did we do that? Huh. Let's reset the code because I'm pretty sure there's something weird in it. Let's press play in it. Okay, let's do 344. Okay, 344. And there we go, that's it. 8611 is our code. So 8611. That was just a representation. You have to reset it by going up to here and pressing the reset button. That was just demonstrating how it's different. How this code here was different to that code. Okay, moving on. Now go ahead and place 32 in there and see what number we get. We'll go ahead and press play. We're also going to press back. Okay, so 32 and see what number we get out now. 32, got number 2. We're going to place 2. And then we'll go ahead and run it in one more time. And it's 34 now. See what we get. 1 second. 34. You got 15. This should be our answer. 15. Okay, there we go. And now we're going to go ahead and answer the last one. Finally, have a go with 04540, 379. It's not really random, is it? That's basically just telling you that it's going to be random. So now how do we define a function? It's in the question. Look. Define def. That's it. DEF. That's it. Simple. Right, okay, moving on. So now we're going to move on to lists. And this is how I was telling you about how you can create a like a grid. So we're going to actually go ahead and demonstrate it now, just an example. What we're going to do now is we're going to say okay, so we'll go ahead and have a list. So we're going to say, let's say we wanted an axis, let's say we wanted columns in like a grid, okay? Like a kind of like ellipse or something like that. So what we're going to do is we're going to say our x is equal to that, okay? X is equal to that, right? Our y is also equal to that as well. And this is just a quick demonstration of it. So we're going to now do a for loop as we did before. For I in range. Range, is that how it's spelled? Yes, it is. Okay. Range, like we did before. Right? And then we're going to say 1 through to 9. Right? And then we're going to go ahead and open a function up here. And we're going to say here, we're going to say, because again, this is just a demonstration. If we go ahead and do print x now, right, we will get everything that is inside of the column. As you can see, it's gone ahead and done a column down. Now, if you want to go ahead and fill the column, you would do for loop inside of it. For j in range, like this. And we'll do it 1 through to 9 because we have the exact same. Okay. And then what we do now is we go ahead and do print, just like this. And we do I, comma, x. That's a j, I, comma, j. And we'll see what that prints. Okay. That wasn't exactly what I was thinking. 1 second. Oh, so the x, comma, y. That's it. X and y, not j. X and y, because that's our variable names up there. And I don't know why it's done it like that particularly. 1 second, I can fix that. Oh yeah, we've got a comma here. There we go. That's it. That's it. Okay. Give us a second here to work this. Well, not work this out, but figure this out because I don't actually. It's not my normal language, Python. I don't really use Python. However, most coding languages are the same. So you've got to learn mistakes before you can succeed in life. Right. Well, in range, yep. Okay. That seems to be okay for me. Looks good to me. Everything looks shipped and shaped. But anyway, you get the point. You get the idea. Like that would create a grid. And if you wanted to have more grids, you would just say for like 3 or something like that, and then you would get like 3 lines. Anyway, that is just like that's how you would do it. My throat is a bit sore. So, given the following list, what would print in the following if the following was called? Hint: nothing will be printed if you type nothing. Right. So, if we print the list 1, right? Now the way lists work, right? Each item in the list always starts with 0. So this is 0. This is 1. This is 2. This is 3, and so forth. So Python is 0. Java is 1. Java. Okay. Number 4 is JavaScript. JavaScript. And then SQL is the last one. Make sure that you've got the capitalizations on those letters, otherwise it won't let you through. Okay, moving forward. Searching. Finally, let's bring everything we've learned together and use randomness both to simulate game play and to search through game moves to try and find the best possible move. This is how computer chess programs work. For example, let's look at a slightly simpler game than chess, battleships. Here we need to try to guess where the ship lies using the grid points. If the location we choose is where the ship is located, we sink the ship. Run the code and let's play. Well, we're not going to play because that's what I was trying to show you earlier, but I didn't actually do it properly. But you get okay, that's because I did it wrong. So that's the only difference wrong. I did it wrong. Okay. So let's go ahead and move down now. Now to see if you have been paying attention. The above code uses program features that we have learnt about in this badge. In the code, which loop we've learnt about was not used? Well, that was the while loop. The while loop is not used at all anywhere here. No while loop at all. The second input that you use input is 7. What will be printed? Okay, let's have a look for the number 7, okay? So what we're going to do now is type in 7 here, and then 7, whatever. And there we go. So it says, oops, that's not even a row in the ocean. So we're going to copy that quote. I'm just going to paste that down there. On what line number is the function printBoard called? So the user does not guess correctly. Well, that's line 50, of course. Okay, for line, so 50. Check my answers. Next task. Okay. Right, the ultimate summary. This badge, we have looked at how randomness can be useful in coding and learned about the selection loops, iteration, and list sequence, the fundamentals of most computer programs. We also learned about the functions. Most randomness in coding isn't really random. It just seems like it because computer-generated randomness is usually sufficient. You can't guess future numbers, but from previous ones, more complicated solutions can be used for lottery generators, cryptography, and you can even use something naturally random like decaying radioactive source to generate truly random numbers. Okay, time to test your knowledge. A random number is chosen by one of the following bits of code. That's obviously going to be this one because it's going to be chosen randomly. If you look at the code, you can see this code is incomplete. It doesn't work. There's no max. And this code here, random, is not even the right library, so you're not even going to be able to do this function down here. How many times will the number be printed if the following code runs? Okay. For I in range 1 through to 5. Okay. For j in range 0 to 1, print I. Okay. That would be, so for I in range, so from 1 to 5, so we'll do it 1 to 5, okay? And then we are going to say for j in range, 0 to 1, okay? Of course, it's going to do it 10 times, isn't it? And if it's not, we will change it. A function can be used how many times in a program? Once. You can only use a function once. The following questions about conditional statements answers true or false. An elif statement always needed when creating a conditional statement. False. And the answer is true. 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 If none of the conditions are met, the else statement will run. The following code, what would be printed? Okay, it's going to random choice list. It's impossible to guess. Yes, it is. We've got 2 questions wrong. So that's obviously going to be a true. And it's okay, I pressed the wrong one, so that's false. And this one is going to be false as well. False. And there we go. Okay, no, 1 second. And this one is going to be false. Not false. False. Okay, why is that wrong now? True. True. Maybe it's because of the capital, that's probably what it is. True. It's probably because it's the capital. Okay, so false. Okay, I'm doing the wrong one is what I'm doing. True. True. We've got 2 now, okay. False. Nearly there. As many times as you like. Yes, you can use a function as many times as you like. And yes, the answer is 10 there because it's doing that. So, yeah, basically it's 10 is what it is. Okay, that's the end of the batch. So thank you for watching. If you did like, make sure to drop a subscribe, like the video, comment, subscribe. Just said that, I don't know why I said that again. And if you want to see more badges in the future, drop them down below. Thank you for watching. My name's Ryan, and I'll see you guys in the next video. Peace.